lab we are going to analyze hypochlorite in bleach. Do you know anything about bleach in Asia? What are the what's bleach actually? What's the chemical properties of bleach? Yeah, they are oxidizers. Yeah. So the bleach, pretty much when you add bleach, they oxidize the target molecules and then change the properties, and as a result, you can de-stain the stain, and you can use them as disinfectants, things like that. So there are two types of bleach. One type is chlorine-based bleach, the other type is non-chlorine-based bleaches. So today we are going to analyze chlorine-based bleach. So in that, actually the compound that we are looking at is sodium chloride. But in addition, usually in pools and things like that, they use calcium hypochlorite, right? In oxygen-based bleaches, actually, they have oxidizing agents based on oxygen, like mostly hydrogen peroxide, sodium percarbonate and sodium perborate. They both got hydrogen peroxide. Basically, sodium perborate, when dissolved in water, it produces hydrogen peroxide. You can see sodium percarbonate up there, the structure is got hydrogen peroxide as that. So how do we make bleach? We react a base with chlorine, and if you react sodium hydroxide with chlorine, it produces sodium hypochlorite, and then reaction is the last. It's a combination. Initially it produces hydrochloric acid. When you have excess sodium hydroxide, immediately hydrochloric acid reacts with sodium hydroxide to produce salt and water. That's the titration experiment that you did last time. Same way you can react calcium hydroxide with chlorine, and then it can produce calcium hypochlorite. So what are the uses of bleach? Mainly we use bleach to de-stain and use as a disinfectant. And even in swimming pools, when you add to water, basically it acts as a disinfectant. In addition to that, I found some interesting uses for bleach in Reader's Digest. You can use for other things, to remove mold, sterilize second-hand items, clean butcher block, brighten up glassware, shine stuff, and even you can add bleach to increase the flower's longevity. That's also interesting. And then, yeah. Okay, let's see how does bleach work. So what is the oxidation state of chlorine in sodium hypochlorite? That's the normal. Normally chloride ion is negative 1, but in bleach you have chlorine plus 1 state. Do you know how? Like here you have ClO, right? Oxygen is 2 negative, right? So this one is 2 negative. So this one is plus. There, when you cancel that out, so this one is going to be another. Sorry. one is overall negative. Okay, so that's why. Oh yeah, sorry, negative. Sorry. This one is +1, -2. So the charge of hypochlorite is -1. So that's why it forms sodium 1ClO, right? So that's why in this case chlorine acts as an oxidizing agent. And then in oxygen-based ones, definitely they are oxidative. So on the chart on the right, you can see some of the oxidation potentials of oxidizing agents. So let's talk about the experiment. The first thing is the safety. Bleach is a strong oxidizing agent, we know that, so you better handle carefully not to touch them or things like that. And it's not too bad, but because you are using diluted samples of bleach, but still it's better to be careful. And then don't mix bleach with anything else other than the pages that use in the experiment. And all the waste that you can drain, dump in drain, and it's okay for this experiment. And in the experiment, now we want to measure the amount of sodium hypochlorite in a sample of bleach. So there is no direct, like last time when you did a titration, you remember that you reacted sodium hydroxide with hydrochloric acid and then used an indicator to find the endpoint. But there is no direct reaction that you can do to titrate sodium hypochlorite. So therefore, we initially react sodium hypochlorite with iodine under acidic conditions, and then that produces iodine I2. Then we measure the amount of this iodine with standard thiosulfate solution. Okay, that's what we are going to do in this experiment. And then again, this iodine is converted to iodide, can be recycled. Okay, so when at this stage, this iodine is actually yellowish color. And when do you remember the test for starch? When you add starch, iodine to starch, it turns like purple blue color, right? So that we use that blue color to find the endpoint. Basically, when no iodine is present, then the blue color disappears, right? So when this reaction completes, then it becomes colorless. So now the procedure. The first step we want to do in this experiment is to prepare the byrate and make that ready for to do the titration. So what do you have in the byrate actually in this experiment? If you read the what will you have in the byrate here? Sodium, yeah, thiosulfate, right? Initially you will have a byrate ready with sodium thiosulfate roughly around 0.1 mole. Make sure that you use the diluted sample, not the original thiosulfate solution that you get from the tank. And then you load that and then have it at 0. I think it's easier to. Last time I noticed that some of you had difficulty reading the amount of titrant when you started somewhere in the middle, because sometimes you tend to use up more than the amount that's So it's probably better to start from 0 for every sample. Because this is only a 25 milliliter burette, so if you use up 20 milliliter in the first experiment, then in the next one also you need 20, so it's better to start with 0. And then in the procedure, remember, first thing you do is to use a pipette and a volumetric flask, and this is a volumetric flask. It has a, you can see the calibration mark here, right, somewhere in the middle. That's the 50 milliliter mark. It's not the top. I heard from the last lab some students fill this up to the top to dilute sample. So that's wrong. So make sure that when you use this one, the volumetric, this pipette to measure 5 milliliter and transfer to this one and add water up to this calibration mark here. And then you make a 1 to 10 dilution. It's the initial amount, concentration is 1 molar. What is the final? 0.1. Yeah. And then make a 250 milliliter beaker ready and add 100 milliliter water, and then you need to add potassium iodide. Potassium iodide is in that over there in the brown squirt bottle. You can see that one of the brown squirt bottles like this. This is hydrochloric acid, but it's similar to this, and you use that white. It's already calibrated to 5 milliliter. The one with the gray one is actually potassium iodide, and you use that one. Don't change the settings and transfer 5 milliliter directly to your beaker. Okay? You just pull it up and then push it down and then measure approximately 5 milliliter. It doesn't have to be exact because here we are using in excess. And then once you add potassium iodide, and then you pipette again using this pipette from here, from this diluted, so then you use the 10 milliliter pipette to measure your bleed sample. And at 10 milliliter, you can see the calibration point here. You have done this one, and add 10 milliliter bleach, and then stir well. After that, you go back to that. Again, we have a hydrochloric acid squirt bottle. Set it to 2 milliliter. You use 1 squirt and add hydrochloric acid. Then immediately you can come to the titration that you can bring it under the bivette and then start the titration. Initially, when you do the titration, you can add sodium thiosulfate in a faster pace, and then you can see that the color changes to yellow. Once it turns yellow, you stop and add 1 milliliter of starch solution, and then start adding sodium thiosulfate dropwise. Once you add starch, it's going to be blue color, so it should disappear at the end point. Okay? And in the data analysis, always make sure to record two correct significant figures, and don't forget units. And concentration of thiosulfate should have 3 significant figures. And then when you read from the burette, you should be able to read to the second decimal point. And then also calculate mass, and then you can record 3 to 4 significant figures based on your calculation. and then the stoichiometry for the reaction. In your calculations, remember that one hypochlorite ion reacts with iodide and produce one iodide, right? And then one iodide reacts with two thiosulfate to produce at the end point to convert that to iodide, right? So the amount of iodine that we use here is, if you have 2 mole and here it's going to be 1 mole of this one, right? For 1 mole you need to remember that also in the calculations. That's it. So we have in the brown squirt bottle potassium iodide and hydrochloric acid. The other solution, these solutions are unknowns are there. And then you need the density of the unknowns, they are on the board listed on both sides.